Welcome to the Bentley Systems training course to learn how to assign properties to concrete structures in Staadpro. Over the next series of videos, we will show you how to assign properties to concrete structures, which will include the topics for assigning properties, assigning specifications, modeling supports, and creating basic primary load cases. In this video, we will learn how to create a new basic primary load case in Staadpro, and then we will learn how to create some new load items within that primary load case. To begin the process of loading your model, we must first go to the appropriate area in the graphical user interface. In your page control area, select the General tab and then the Load and Definition sub-tab. In the Load and Definition dialog, we can see three groups are available, and we're going to be focusing on our load case details section. This is where we are going to define some basic load cases and also create some load items such as self-weight or member loads. In addition, Staadpro does have the ability to generate some code forces for you, including wind load, snow load, and seismic load, and this can be done through the definition section. To create a new basic primary load case, I'm going to highlight my load case details item, and then I'm going to go ahead and click on the Add button. This will automatically bring me to the Add New Load Cases dialog, and the primary option is going to be selected by default. This is what we want to generate a new load case. We can enter a load number. I'm going to use load number 1. And a title. This can be anything you choose. I usually like to pick something descriptive like dead load. And then we can enter a loading type, and here we have several different loading types available. And I'm going to select the dead load option. Now this loading type is used to associate this load case with the code definition of a load type. This type of association needs to be done in order to make sure Staadpro will automatically be able to generate some load combinations for us. After you enter all of your basic primary load case information, I can go ahead and click Add, and a new load case has been added. Now I can enter as many load cases as I need for my particular model, and for this model I'm going to be generating a dead load case and a live load case. So my load number 2 has automatically been set for me, and I'm going to enter a title of live load. And then again, I'm going to select my appropriate load type of live. When choosing live load, I also have the option to say whether or not it's reducible per the UBC or IBC codes, and I can select this checkbox if it's applicable to my particular model. And then I'm going to go ahead and click Add, followed by Close. And here I can see that the dead load and live load case have now been created within this load cases details section. Before I populate each load case with the load items that would be applicable to it, I'm going to first investigate what my input units are. And for this model, currently I'm set to kips and inches. Now I will eventually be applying a uniform member force to some of the beams in this model, and I'd rather enter this information in kips and feet instead of kips and inches. So at this point, before I create my load items, I'm going to change my input units. Now I can't change my input units from this load and definition page in the page control area, so all I'm going to do at this point is select a different tab and then reset my input units, and then I can return to that load and definition area. Up in the Structure toolbar, I'm going to click on my Input Units icon, and I'm going to change my length units to feet instead of inches, and my force unit I'm going to keep at kilopounds. Then I'm going to go ahead and click OK. I can see my input units have now changed, and I'm going to return to this Load and Definition area where I can expand my load case details. I am now ready to define my load items for each of my load cases, my dead load and my live load. In order to add a load item within a load case, I need to first highlight my appropriate load case, and I'm going to start with dead load. And then I can click on this Add button in the Load and Definition dialog. This will automatically bring me to the Add New Load Items dialog, where I can enter a variety of different load types within the currently selected load case. The first load item that is automatically selected is the self-weight load. Now Staadpro does have the ability to calculate the self-weight of the structure and then apply it as a uniformly distributed load if we specify this self-weight load item. When specifying our self-weight load, we need to enter a direction and a factor. For our particular model, and for most models, your vertical axis is going to be your y direction. So I'm going to select our y axis, and I'm going to enter a factor of -1, which will indicate that the self-weight should be acting in the downward y direction. Then I can go ahead and click Add, and now I've completed my assignment for my self-weight load. Now before leaving this dialog, I can add as many different load types that are applicable to that dead load case. So next, I'm going to apply some uniformly distributed member loads. So I'm going to select this member load option followed by the uniform force option. Now here I can enter my appropriate force for this structure, and I'm going to enter a force of -0.05 kips per foot, and of course the negative indicates a downward acting force. For the direction, I am going to use the global y direction, but you'll also notice that for member loads I can actually apply it for the member local axis as well. Now if I set all these d parameters equal to 0, this is going to be a uniform force along the entire length of the member down the center line of the beam, which for this particular model would be appropriate. If I also look in this graphic, you can see that I can actually use these parameters to specify other different types of loadings. Once you enter all of your uniform force items, then I'm going to go ahead and click the Add button followed by Close, and here I can see that the two load items that I created within that dead load case are now available. The question mark in front of each type of load indicates that this is the type of load that needs to then be manually assigned to my model. So that would be the next step. To assign the self-weight load to the model, I'd want to go ahead and highlight that load type, and I can see all of my assignment methods are available. Now for the self-weight, this would be applicable to all of the elements in the model. So I'm going to use the Assign to View option to assign it to everything. To complete this assignment, I'm going to go ahead and click on this Assign button, and then I'm going to confirm this operation by clicking Yes. I'm now ready to go ahead and assign that uniform member load as well. So I'm going to go ahead and highlight the uniform member load, and then I'm going to deselect everything in the model, and then I'm going to select the beams parallel to the global z-axis. To do that, I can just go up to my menu bar and say Select, Beams Parallel to, and then I'll select this Z option. And here I'll select all the beams parallel to the global Z. I'm going to change my assignment method to Assign to Selected Beams. And then I'm going to go ahead and click Assign. And then I'll click Yes. Now as you can see, after you make each assignment, your icon in front of the load item is going to change, and now this indicates that that load type has now been assigned to the model. Now this uniform member force has been applied to the model, and if we could see very closely, we do have some load arrows, but they might be a little hard to see on your screen if your scales are not set appropriately. I can adjust the scale of my load arrows by going up to my Structure toolbar, and I can click on this scale icon. Right now it's currently set at this Scales tab, which is appropriate. I'm going to select the Apply Immediately checkbox, and for my Distributed Force option, I'm going to click this down arrow until I start to see my loads appearing a little bit more clearly on my screen. Once your graphic looks a little bit more appropriate, I can go ahead and click OK. And this might be a good way to just double check to make sure that the loads were applied as you had intended. I am now ready to populate my live load case with some load items as well. To do this, I'm going to highlight my live load case, and then click on the Add button. This is going to bring me back to the Add New Load Items dialog. And for this load case, I'm going to be defining a floor load and some uniform plate loads. Over in the left pane, I'm going to select my first load item, which will be a floor load. Now this will be used to apply a panel load, which will be distributed to surrounding beams based on a one-way or two-way distribution. The first thing I'm going to enter is my pressure. Again, I'm going to enter this as a negative value to indicate that this is a downward acting force. I'm going to enter the magnitude as 0.05. I'm going to also select the direction as the global Y direction. Now for a floor load, this doesn't get assigned after you leave this dialog. It actually gets assigned at the same time, and I have several different assignment methods I can do. For this particular model, I'm going to select the Y range option, and I happen to know that the roof level is at a Y equals 14-foot coordinate location. So what I'm going to do is I'm going to enter my minimum and maximum values at 14 feet for my global Y direction, and then the last thing I need to do is select a distribution. Now by default it's going to be a two-way distribution, so it's going to apply the load in two ways to the surrounding beams, or I can select a one-way distribution if that's more applicable to how I would expect the loads to be distributed in my particular model. Once you are done entering your floor load item, I can go ahead and click Add, and now I'm ready to apply more loads if they are applicable to the live load case. I'm also going to be applying some plate loads. So I'm going to go ahead and select the plate load option, and here you can see I have several different options of plate loads available, and I'm going to select just the pressure on full plate option. Again, I can just enter a magnitude. I'm going to enter negative 0.05 kips a square foot, and I'm going to go towards the global Y direction. But since this is a plate load, I also have the option to do the local axis as well. I'm then going to go ahead and click on the Add button, and I'm going to follow that up by clicking Close. Now I can see that my two load items have been added within my live load case. I can see that my first load, which is my floor load, I'm going to notice that the icon adjacent to this indicates that this load has already been applied to the model. Now if I take a look at the model, I can see what the distributed loads ended up being on each member in the model, and the shaded areas basically indicate the different tributary areas that were applied to each beam member. So there's no further step required when doing a floor load. And again, we entered a Y range, and this level just happens to be at 14 feet. Next, I'm going to apply my plate loads to the model. So I'm going to highlight my plate load item, and I'm going to go ahead and assign this to every plate in the model. So the easiest way to do that is to select this Assign to View option, and then I'm going to go ahead and click Assign, and then I'm going to confirm that operation by clicking Yes. And here I can see that basically all the plates in the model were grabbed for that plate load definition. Now at this point we've completed creating our basic primary load cases and our basic primary load items. For Staadpro, you can add as many load cases as you need for your particular model and as many load cases that are needed within those load cases.